Hello and welcome to another video on orbital mechanics. I'm still going through the book Orbital Mechanics for Engineering Students by Howard D. Curtis, 4th edition. I'm up to problem 3.5 in the book, and as you can see on the left, problem 3.5 asks, calculate the time required to fly from P to B in terms of eccentricity E and the period T. B lies on the minor axis. So it says B lies on the minor axis, which is here. Oh, sorry. I'm going to draw the rest of I'm going to draw the orbit. So there is B, and the way we draw our calculations is to put the Q at the point above B, so it's there, and so that means that is E, which is 90 degrees, which is pi over 2. And so 3.5, we have M E equals E minus eccentricity sine E, and E is pi over 2, so pi over 2, and the sine of pi over 2 is 1, so just this, and we are looking in terms of T, and so ME is 2 pi over T, and so we'll just rearrange this. T equals 1 over 4 minus E over pi, just moving those things across, and then bring our period over here. So that's that. And then 3.6, it says if the eccentricity of the elliptical orbit is 0.3, calculate in terms of period T the time required to fly from P to B. So in this particular one, it's got the focal point. Focal point is here in each question. 90 degrees. So in this case, it is there. So that's number 1, that's number 2. And this is 90 degrees. And it wants the eccentricity, sorry, the T in terms of time, in terms of T again. So again, we have this equation minus E, ME. We can just use the big equation. We have enough information to do it. So it is 2 tan to minus 1 square root of 1 minus E. We are given E is 1.3, and then tan theta over 2, that's 45, which is going to be 1 in this case, minus 1E squared over sine theta, which is 90, and then 1 plus E cos theta. If you plug in, E equals 0.3 and theta equals pi over 2, which is 90 degrees. ME equal to 0.9799. That's not what we're looking for. We're looking for in terms of T, so that is equal to 2 pi over T. So in order to get in terms of T, we're just going to do ME over 2 pi T equals T. So T equals 0.156 T. That's the answer. And then 3.7 is, we are now going to use the red pen. 3.7 is saying we want to go over to here, and this is R, and this is 2R, and this is theta, and so to do that, 3.7, we are saying that r equals h squared over mu times 1 over 1 plus e, because this is at 0 degrees, so sine cos of 0 is 1, and 2r equals h squared over mu 1 plus 1e cos theta. Now we don't know theta, but we can equate these two. We can move the 2 down to here, and we can say that these are equal. We can rearrange. We get 1 plus e equals 2 plus 2 e cos theta, and then theta equals cos inverse of e minus 1 over 2e, which equals 120 degrees. And now that we have our theta, we can just put it back into this equation and do exactly the same thing. We end up with t equals 0.1704 t. And the MATLAB will be provided in the description for those. Thank you very much. If you think I've made a mistake or you have any questions, leave them in the comments. Thank you. Bye-bye.